All right, everyone, this is part 2 of lesson 7.3. I ran into some complications. Problem number 1 is I realized that trying to do page 240 and 241 together would end up as a super long lesson and a super long video. I wanted to split it up in case you only need to look at either 240 or 241 on their own. The second problem is I ran through almost this entire thing and made a pretty big error. So if you're worried about not understanding this, or if you're bummed out about problems that you just completely do incorrectly and you have to start all over, join the club. I'm the teacher and I still do that. So instead of erasing everything, I'm going to keep it here and just walk you through how we're going to set up this problem, and I'll show you what I did wrong and how you can avoid doing the same thing. So first, I'll read you the question. Francisco and his aunt are making a quilt, and the finished quilt is going to be 6 feet by 7.5 feet. And the quilt pieces, the little fabric squares, are actually going to be 1/4 of a foot by 1/4 of a foot. So this should remind you of problem number 3. Remember when we actually made the drawing of the square foot? Except in their case, the tiles were not 1/4 of a foot, they were 1/3. And we found out that if you take 1/3 and you take another third and then a third, that would be 3/3, also known as a foot. That would give us 1 full foot. 1/3 of a foot plus another third plus another third. For problem 4, we're going to do the same thing because the first question is going to be how many fabric squares will fit along the 6-foot side. So the first thing we want to do is find out how many fourths would make up just 1 foot. And that's where this picture comes in here. If you can see this, it looks a little light on my screen. But if you can see this, I basically drew a diagram very similar to number 3, where I said, well, this fabric square is 1/4 of a foot. If I had another, that'd be 2/4, that's half of a foot, 3/4, 4/4. So I found out to make 1 foot, you would need 4 fabric squares. Not 1 square foot, just 1 regular foot. So if we know 1 foot takes 4 of these squares, do we know how we could find out 6 feet? And if 1 foot is 4, then we would just have to do the 1 foot, then another 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 foot, until we had 6 of these. And of course, you could just draw out 4, then another 4, but that's crazy. We have an easier way to do that. Let's take the 4 of 1 foot, and let's just do it 6 times. And that will tell you how many fabric squares fit on the 6-foot side. We can fit 4 in every foot, so 4 times 6 will give us the answer to A. Now, letter B is pretty much the exact same thing, except there's a difference. We're not dealing with just 7 feet. We can't just do 4 times 7. We have to do 4 times 7.5. And I originally threw out 2 different ways to solve that, but to simplify it, I'm going to just stick with 1 way. I'm actually going to go against what we did in 7.2 because I think this will be easier. We can also multiply a whole number by a mixed number by just multiplying them by each piece. So we can do 4 times 7, and that'll give us the first part of the answer. But we can also do 4 times 1/2, and that will give us the second part of the answer. And for this one, maybe I'll show you what I mean. 4 times 7, I know, is 28. And 4 times 1/2, it gets a little tricky. It's actually, if it helps, 4 times 1/2 is basically like saying 4 divided by 2. It's just taking the 4 and literally splitting them right in the middle. So what's half of 4? I know that it's 2. So the actual answer here is we would just combine this guy, and that will give you your answer for part B. Okay, does that make sense for how we multiplied the mixed number in this case? Now, part C is where things get a little fun, and you might need a calculator, or you might need some lattice multiplication, whatever floats your boat. They're going to want to know how many fabric squares they need for the entire quilt. And that's where this diagram comes in. And the mistake I made when I first did this lesson was I called this the area that we were finding. And we're kind of finding the area, but we're finding the area in terms of fabric squares, but it's not going to be the area in terms of footage. Here's the good news. The answer from A is going to be one side. That's going to tell us how many fabric squares. We already know that along the 6-foot side, we have this many. Once you've solved this equation, you have this many fabric squares. So you can just put that answer right here. And you also know the answer to B once you add these two together. And that can be your length. So you'll have the answer to A here and the answer to B here. So basically this quilt, which I'm not going to take this video, but basically one side is going to have a bunch of fabric squares. That's not accurate, but it's going to look like something like that. And if you want to find the total fabric squares, all you have to do is take the answer to A, multiply it by the answer to B. And that will tell you exactly how many fabric squares you'll have in your entire quilt. And if it helps you out, your answer will be, it'll be big. It'll be less than 1,000, but more than 500, if that is a good hint. So I wanted to talk about letter D. Letter D, we're going to go back to the original dimensions. We're not going to talk about fabric squares anymore. We're done with the fabric squares. Now it's only going to be the area of the quilt according to footage, square footage, in fact. So instead of having a number of fabric squares as your length and width, we're going to have our actual length and width come back into play. And our actual length and width was 6 feet by 7.5 feet. And we know to find the area equals length times width. Don't forget it. So all we need to do is plug in area equals, length and width is the same as width and length. Area equals 6 times 7.5. And to find this answer, you can use the same strategy that we used for letter B, except we're not going to do 4 times 7.5 in this case. We're doing 6 times 7.5. So you can break it down. You can do 6 times 7 and then 6 times a half. Take those two answers, put them together, and that will give you your area. I guarantee it. Okay, I left a lot of blanks out there. It feels like I'm leaving you hanging, but I want you to see if you can fill in those blanks, guys. I want to see if you can do this. So last piece here, I'm going to take a look at number 5. I'm getting a little hungry, so apologies if this comes off a little too fast. So Marguerite has a piece of checkered cloth like the one shown below. She measured one checker square and found that it was a 1/2 inch by 1/2 inch. The piece of cloth has 15 rows and 20 squares each. So this is almost like a carbon copy of what we just did above. We're going to be talking about, I'm guessing they're going to want to know how many checker squares. Yes. I'm guessing they'll also want to know the area at the end. So first, they already told us the dimensions in checker squares. So they told us one is going to have 15 rows of checker squares, and the other will have 20 rows. So 15, 20 different times. I'm going to repeat that and listen closely. 15, 20 times. Can you think of a fast way besides going 15 plus 15 plus 15 plus 15? Is there a faster way to find out what is a row of 15 20 times? Okay, so that's going to tell you, if you can figure out that little riddle, how you can do 15 and 20 and find the total. That will give you the answer to letter A. Now, the tricky part is where I'll jump in and devote a little more time. They want to know the dimensions of the piece of cloth. By that, they mean literally the the inches, because this is not 15 inches. This is 15, what are we working with this time? Checker squares. And a checker square is not an inch. Okay, how much is a checker square? If you look in the corner, a checker square is only 1/2 of an inch. So there's two ways you can do this. You can take the total number of checker squares and split them in half, which I think you could probably do for this guy. You can split 20 in half, right? Half of 20 is 10. Or you can do the manual way, the harder way, which is to just count your halves. 1/2 plus 1/2 is a whole, so that's one whole. 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6, 6.5, 7, 7.5. The hard part is, if you noticed, I almost lost count. So sometimes the easier way is just literally to do half of 15 if you know how to do it. And half of 15 is 7.5. So here are your dimensions. These are going to be inches. 7, you may have also noticed 7.5, just a quick reminder, is the same as 7.5. So in case you guys were a little confused by that, 7.5 is the same as 7.5. So once you have the dimensions, which we do, 10 by 7.5 inches, we should be able to find the area now. Because remember how we find area. Bam, right there. So you now know your length, you now know your width, and it's going to be up to you to solve that area model. Okay, you can see by looking at the time why I split this up into 2 videos. It's a lot, and of course, as always, if this hurts your brain, it's okay, take a break, and if this doesn't work for you, you know, it happens sometimes, but I'm hoping this at least, if you have a parent or a guardian or another helper with you, hopefully this made some sense in some ways. If not, go ahead, hit me up, ask more questions. We'll go ahead and get this thing figured out. All right, I will see you guys for lesson 7-4. Goodbye.